Hello, my friends. I'm Clover. This is Genuinely Approachable Sudoku, and I have a rare announcement before I start solving this puzzle. SudokuCon 2025 is happening in just a couple of months. It starts on April 3rd, 2025. That's in Boston, Massachusetts, US. And ticket sales opened just, I think in November, so they opened fairly recently. And I have been asked to make an appeal to you guys if you have not yet purchased your ticket for SudokuCon. Go to sudokucon.com, click on the tickets link, and go ahead and pick up your ticket. It helps us know how many people are actually coming to the event. It helps us plan for catering and for scheduling, things like that. So obviously you're free if you're coming to join us to buy a ticket right up until the time of the con. But it would really help us out if you know for sure that you're going to be there, if you would go ahead and make your ticket purchase. So sudokucon.com. Philip and I are going to be there. Alas, Bill is too far away to make it, but Philip is going to be there and is going to be leading a workshop. I'm going to be also not leading a workshop, but I'm going to be involved in one of the solving contests that's going to take place there. It should be accessible to even people who are not incredibly serious Sudoku solvers or who aren't Sudoku setters. We really went out of our way to make sure that it wouldn't be an event exclusively for people who design puzzles, but just an event for everybody who is interested in puzzles. Hello, darling. From any direction, whether you're just kind of intrigued by like the math and the art and the design behind puzzles, whether you enjoy solving, you enjoy creating puzzles, you just enjoy watching gas, there will be stuff there for you to get into. So yeah, go check it out. Go ahead and purchase your ticket. We will be there in April, and we're looking forward to seeing some of you guys who are fans of this channel. But that's my announcement for today, and let's solve a puzzle together. So me and my cat and you guys today are solving Revenge of the Vault by Philip Newman. This is a between line Sudoku. And what does that mean? We're placing the digits 1 through 9 once each in each row, each column, and each outlined 3x3 region. And in addition to that, we have some lines in the grid that kind of dead end into some circles. And the way these work is whatever numbers you put in the circles, the numbers that are on the line have to have values in between those two values. So for instance, if we found out that these guys were like 1 and 7, then these two numbers would both have to be somewhere in between 1 and 7. Like they couldn't be 8, they couldn't be 9. Obviously we couldn't have another 1 or 7. They'd have to be in between, so 2, 3, 4, 5, or 6. So let's have a look. So whenever we have an 8 on a line, there has to be a 9 on one end of that line, because otherwise you wouldn't be able to fit the 8 in between, because there has to be a number there that's higher than 8. So we can't put a 9 in this circle, so we're going to have to put a 9 in this circle. Now, that means we can't put a 9 in this circle, so we're going to have to put a 9 here. And we have symmetrical deductions over here as well, so we need a 1 in one of these circles because there's a 2 on the line. We have to put the 2 in between 1 and something else, so that will be a 1. Now we need a 1 in one of these circles, so we're going to have to put a 1 here. That has almost filled up the central column and the central row. We in fact have all of our odd digits in this column and in this row. So let's do a little bit of work with those. So in the central row, row 5, if we look at this cell, we know it can't have 1, 3, 5, 7, or 9, so it's only even digits, and that makes it either a 2 or 6 because it sees a 4 and an 8 in its column. But its value also has to be in between 1 and 5, so it can't be a 6, it must be a 2. Similarly, this can only be a 4 or an 8 by Sudoku, but it can't be a 4 because 4 is not in between 5 and 9. So this is going to be an 8. And then we're going to place a 4 and a 6 on the ends here. We have a 4 in the region, so that's going to be our 6, that's going to be our 4. Let's do some work with this column now. So we need 2, 4, 6, and 8 in this column. One of those has to go on this line between 1 and 5, so it has to be 2 or 4, and because there's a 4 in the row, that's going to be my 2. One of those will go on this line, it's a 6 or an 8, there's a 6 in this row, so that's going to be an 8. And now we just still need to place a 4 and a 6. These digits are going to be 1, 4, 6, and 9, and I can clean those up based on this 4 and this 6 here. Okay, I found the next bit of this puzzle to be actually absolutely fascinating. I found this really compelling. Kudos to Philip for the logic in this. So we're gonna look at the intersection of these top two between lines and then these bottom right two between lines. And we're gonna try to figure out what these circles can be and what is allowed to go along these lines. And it took me a little while to see this myself, so don't beat yourself up if you got yourself a dinosaur today for a slow solve. That is completely fine. Now, this is a 1, so this is going to be the low end of the between line. The lowest these guys could be, and ignore everything else in the grid, in theory would be 2 and 3, which means this has to be 4 or greater to be the bigger digit. So that's a minimum of 4. What is the biggest this guy can be? Well, the biggest it can be, these could be 6 and 7, or sorry, these can be 7 and 8 in theory, remembering we're ignoring everything else in the grid. So the biggest it could be is 6. So if we ignore everything else in the grid except for just like those two lines, then we know this cell has to be 4, 5, or 6. However, this can't be a 3, this has to be 4 or greater. So this can't be a 4 because otherwise it wouldn't be bigger than a number that's 4 or greater. Similarly, this can't be, we can't have an 8 on this line. So these can be actually at most 6 and 7. So this can't be a 6. It wouldn't be able to be lower than both of these two digits, so that's a 5. And that tells us this is exactly a 4 because it's not 2 or 3 and it goes between 1 and 5. And that's going to clear this up, and it's going to place a 4 in the central region. These now have to be exactly 6 and 7, and because there's a 6 in this region, we put a 6 there and a 7 there. Let's do the other corner before we do anything else. So we'll do this one a little more quickly. I'm going to kind of combine some steps into one here. The minimum these could be would be 3 and 4, because there's a 2 there already, so the minimum there is going to be a 5. And the maximum these guys could be would be 6 and 8, because there's a 7 in the region already, so the maximum here is going to be 5. So that must be exactly a 5, which places 3 and 4 on this line. And this has to be a 6, 7, or 8. It sees a 7, it sees an 8, so it's a 6. And that is going to place a 6 in the middle region. Okay, so let's have a look at our remaining lines. So in this column, I need the digits 6, 7, 8, and 9. This can't be 8 or 9, or it can't be 6 and it can't be 8 or 9 because there's an 8 and 9 in the region, so it's 6 or 7. This can't be 6 or 7, so it's 8 or 9. However, 9 cannot go on a between line because 9 is never between two other digits. So that's going to be an 8 with a 9 on the end, and then this is our 6 or 7. That 6 makes it a 7, and this is now a 6. This line, symmetrically, we need 1, 2, 3, and 4. This can't be 1 or 2. This can't be 3 or 4. It also can't be 1 because 1 can't go on the between line. So that's going to be a 2 with a 1 as its partner. The 4 will make this a 3 and place a 4 right there. Now finally, we can finish these rows. We don't really need to make reference to these lines because these are unrestricted since their ends are 1 and 9, but we can go ahead and do that anyways, just kind of for aesthetic reasons. So we have 6s here and here, that's going to place a 6 on the line right there. And we need 3, 7, and 8 in this row. That can't be a 3, that can't be a 7. Oh, we actually don't get to finish that just yet, but we will shortly. We have 4s here, here, and here. That places a 4 on the line right there. And these are going to be 2, 3, and 7. That can't be a 3, and this cannot be a 7. Now, if we look at these regions, we kind of have these fish-shaped arrangements of digits. We have a 1 there that sees those two cells, and so the only place for a 1 in the region is right there. That places a 9 and a 1 in the central region. The 9 here sees those two cells, so the 9 in this region is going to have to be right here. These digits remaining in the region are 5 and 7. These guys are 3 and 5. That eliminates a 3 here, which gives us a 3 right there, and eliminates 3 and 7 there, giving us a 2, 3, 7, which resolves the 7, 8 pair. This 3 sees both of these cells, and there's no other 3 in this region, so 3 can only go there. I still need a 7 and a 9 to finish that region. Down here, I still need a 1, a 3, and a 7. 7 sees these two cells, that'll be my 7, 1, and 3. Now these are going to be 4 and 8. These are going to be 1 and 5 to finish off the region. I'm going to finish off this column with a 2. It's not going to go there, with a 2 and a 6. And these guys are going to be 5 and 9. And in the middle here, I need a 2, 5 pair to finish this row. And I need a 1 and an 8 to finish this row. Up here, what I need is a 5 and an 8. That's now a 2 and a 5, and then I can finish the grid by placing my last two digits, a 2 and a 9. And that is how you solve Philip Newman's Revenge of the Vault. I liked that one. That had a little bit more intricacy to it than some gas puzzles. There's a little bit of a spicy one. I hope you liked it too. If you haven't tried it yet, the link to do so is in the description below this video. And I will see you again 3 days from now.